Good evening. Welcome you all for today's session flip-flops, that is our T flip-flop. In this session we are going to discuss about T flip-flop. In the previous sessions we discussed about SR flip-flop and JK flip-flop, and now we are going to discuss about T flip-flop, which represents toggle flip-flop. So these are the features of T flip-flop and symbol of T flip-flop. The features are: the name T flip-flop is termed from the nature of toggling operation. The major applications of T flip-flop are counters and control circuits. T flip-flop is modified from form of JK flip-flop, making it to operate in toggle region. Whenever the clock signal is low, the input is never going to affect the output state. And here you can see the symbol of T flip-flop, where you have a clock pulse, then toggle pin T, Q input and Q bar inverted input. Q, always Q and Q bar or vice versa to each other. So this is the truth table of T flip-flop, where we have T input, then previous state and next state. Previous state is represented by Q previous and next state, that is Q bar. Previous state Q and next state Q bar. So here if 0 0, if your T flip-flop is 0 0, then your next state will be 1. Okay, so 0 0 0 1 1 0 1 1. So in 0 0 you will have 1 0. In 0 1 you will have 0 1, that is the same state, and 1 0 1 1, that is also the same state, and 1 1 you have 1. So this is the next state. If your present state is 0, then your next state will be vice versa. So you can see the complement terms with your present state and next state. If your previous state is 0, then next state will be 1. If your previous state is 1, then next state will be 0. So the same concept is represented in this truth table. So the operations and applications of T flip-flop. When the T input is low, when the next state of the T flip-flop is same as the present state. If T is equal to 0 and present state is equal to 0, then next state is equal to 0. If T is equal to 1 and present state is equal to 1, then next state is equal to 1. When the T input is high and during the positive transition of the clock signal, the next state of the T flip-flop is the inverse of the present state. So you can see here, if T is equal to 1 and present state is equal to 0, then the next state is equal to 1. If T is equal to 1 and present state is equal to 1, then the next state is equal to 0. So you can compare both when T is equal to low and when T is equal to high. So when T is equal to low, the next state is low. When T is equal to 1, the next state is 1. In present state, both low and high is represented here. So coming back to applications, coming to the applications of T flip-flop, T flip-flops are mainly used in frequency division circuits. T flip-flops are mainly used in frequency division circuits, then 2-bit parallel load registers, counters, particularly in binary counters, then frequency dividers, binary addition devices, and 2-bit parallel load registers. These are all the applications of T flip-flop. And we can also see about the advantages and disadvantages of T flip-flop. So the main advantage of T flip-flops are it has two inputs, toggle and a clock input. It has two inputs, both toggle and a clock input. They are good for counters because the values get complemented when the clock is triggered. So the main disadvantage, only one disadvantage in T flip-flop is the state can only be determined if the previous state is known and devices are not available as integrated circuits. These are all about T flip-flop. Thank you.